Okay, so we are going to talk a lot about moving around in 3 dimensions in this class. And in order to do that, we need to talk about how we draw that, how we represent that. The big problem is going to be that we are trying to represent 3D images in 2 dimensions. So most of the time when we look at a 3D image, if it's an image of real people, we can see what's going on. So for example, here's a couple of kids sitting on a rock. Looks like they're in front of most of the rock, and there's some trees in the background. But many of you are probably familiar with this sort of an optical illusion here. These are the same kids a week later, and somehow either the little boy has turned into a giant, or the little girl has shrunk, or there's something that's weird about this 2-dimensional image. So if you want to find out more about how these sorts of optical illusions are done, you can search for Ames Room, but that's not really the point of this talk. What I want to do is talk about how we're going to draw 3D axes on 2D pieces of paper or on a screen in such a way that we can all agree on what's in front of what direction everything is in, etc. So if we want to just draw a one-dimensional axis, that's pretty easy, right? Here's an axis with that I've labeled Y. Y clearly points to the right. And if I add a Z-axis, most of us can agree that this is the Z-axis is going to be perpendicular to the Y-axis, and in this image it sure looks to me like Z is pointing up and Y is pointing off to the right. The trouble arises when we add that third dimension to the image, right? We can all agree that X is perpendicular to Y, X is perpendicular to Z, right? All the axes are perpendicular to one another. But what sometimes is harder to agree on is which way is X pointing? Is X pointing out of the screen, sort of towards you, or is it pointing into the screen, away from you? And the problem is that different people actually view this differently. So let me try and give you some understanding of why people see this differently. To start with, I want you to look at these two cubes. They are 5-sided. Think of it as like a box with a hole in the front. So if we look at it, this is sort of the box viewed from below. There's the bottom of the box, and the two sides of the box are in pink, and then the top of the box. You can kind of see the inside of the top of the box, but the bottom of the box we're seeing from underneath. And if we move our camera, we can imagine that now we're looking down on the box, and so this is the top of the box. We see the inside of the bottom of the box, the inside of the left wall here, the outside of the right wall here, and of course the black is the very back of the box. So take a look at this slide until you can see that this is sort of viewed from below and this one's viewed from above, and you understand what's going on here. So what I want to do is show you that this XYZ axis that we had before, depending on how we lay it on the box, you may see that X is either pointing out of the screen or into the screen. So if I overlay that XYZ axis onto the box so that the Z-axis is along the front edge of the box, the Y-axis is along the front edge of the box, and you can see I've got sort of the X-axis is down and back along the bottom edge. So you can see that in this image, X is actually pointing away from you, right? This is down along the edge of the box, away from you, kind of into the screen. On the other hand, if I overlay the axis onto the box like this, you can see the x-axis is still pointing in the same direction, y in the same direction, z in the same direction. But now I've got it sort of the yz axis or axes are along the back, sort of inside back of the box, right? And the x is starting at the back and moving out. Now it's pretty clear that x is pointing towards you, not away from you, right? So depending on how we interpret the picture, we may see it in one of two different ways, or maybe more than two different ways. So we're going to agree that for the purposes of our notation, if you have an axis that's kind of pointing out and down, down and to the left, that means towards you. So in this picture, X is pointing out of the image towards you. And if I were to draw it in this direction, sort of up and to the right, then that would be an axis that's going into the page, into the screen. Now, it turns out that if we look at the axes that we have drawn here, not the extra one I did, but if we just look at this X, Y, Z set of axes, this makes a right-handed coordinate frame. So let's talk about what that means. So a right-handed coordinate frame lets you know, given two of the axes in a three-dimensional coordinate system, you can figure out which direction the third axis points. So let's talk about how you know what direction things point in. A right-handed coordinate frame is one in which, if you know your X and Y axis, you can automatically know the direction of the Z axis. Similarly, if you know your Y and Z axis. So here's how you figure out whether a coordinate system is right-handed, and also if you have a right-handed coordinate frame, how you figure out the third axis using the right-hand rule. So this one is just if you are given X and Y, how do you figure out Z? So if you're given two axes that are X and Y, what you want to do is you want to start by sticking your hand out so that your fingers of your right hand, and it's got to be the right hand, that's why we call it the right-handed coordinate system, and you want to point those fingers so that they're pointing in the positive X direction, right, in the positive X direction. And then you adjust your fingers. Of course, there's an infinite number of positions where you can have your hand so that the fingers are pointing in the positive X position. But what you want to do is adjust your fingers, or adjust your hand, so that your palm is facing in the Y direction. So your fingers are pointing along positive X, and your palm is facing in the positive Y direction. And if you hold your hand that way, then you should be able to curl your fingers from X towards Y. And if you do that, your thumb will naturally point to Z. So let's look at an example. Here's an X and a Y axis. And of course, there's a lot of ways that we could point our hand so that our fingers are pointing in the sort of X direction. But, if our thumb were down, then our palm, if that's our right hand, of course, then if our thumb is down, our palm is going to be facing away from Y, right? But we don't want to do that. What we want to do is hold your right hand so that your fingers are pointing in the positive X direction and the palm of your hand is facing in the positive Y direction. Remember, this down and to the left arrow means it's coming out of the page, so the palm of this hand is pointing out of the page. And if you do it right, you'll see that when you curve your fingers from positive X and then you curve them towards positive Y and stick your thumb out, your thumb is going to point in the positive Z direction. So there you go. Positive Z in this case is going to be straight up. Now that's great if you know X and Y, but what if you know other axes? Well, here's the chart. It kind of goes from X to Y to Z in a sort of a circle. So if you already know the directions of the X and Y axis, then you start by pointing, so this is kind of your fingers, and making sure the fingers of your right hand are pointing towards X, and make sure it's your right hand. If you're left-handed, you have to sit on your left hand while you do this. And then you face your palm towards the positive Y, right? And then so you can curl your fingers from X to Y. and your thumb is going to point at Z. So as I said here, if you start at X and you curl to Y, you end up at Z. And similarly, if you start at Y, facing your palm towards Z so your fingers can curl from Y to Z, then your thumb is going to point in the X direction. And if you start at Z with your palm facing X and you can curl your fingers from Z to X, then you end up computing Y. So let's just practice on these ones. I'm going to point my fingers towards X, and X is coming out of the page towards me, right? So I'm kind of holding this screen up in front of me, and the only way I can get my fingers, so I'm holding my hand so that I'm pointing it towards me, but the only way that I can get it so that I can point my right hand towards me but have my palm facing Y is if I sort of turn my right hand upside down and hold it over my shoulder. Then I can curl from X to Y, which is to the left, and I discover that my thumb is pointing downwards. So there's the Z-axis. In this next one, this one here, I'm going to point my fingers up in the X direction. So I'm holding my hand above my head, pointing my fingers up, and I'm going to point my palm to the right side. So when I curl my fingers, they go from X to Y. And once I've curled my fingers, my thumb is pointing sort of into the screen. So, oops, let's draw it. So we have Z, all right? Let's take a look at this third example now. Now, we have Y and Z. So remember, X goes to Y goes to Z, Z goes to X. So we're going to go Y to Z. So I'm going to put my fingers in the direction of the Y axis so that my palm is facing Z. So now I have my this is my palm, right? My fingers my hand is stretched out to the right because Y is going to the right, but my palm is facing upwards so that when I curl my fingers from the right to up, my thumb is pointing backwards, sort of behind me. So there's X. All right, let's try this one. We have X and Z, and this is one that people always mess up on, well, frequently mess up on, because they think, I go from X to Z because X comes before Z. But remember, X to Y, Y to Z, Z to X. So I'm going to put my fingers in the direction of the Z axis so that my palm is facing the X direction. So I guess my hand is straight out, but my palm is down. So when I curl my fingers down, my thumb is pointing into the screen, right? So to draw the Y-axis into the screen, I have to sort of go up and to the right, because we agreed that when we're drawing a line that's into the screen, we're going to go up and to the right. And then this last one, we have the Y and Z axes, so we want to go from Y. Our fingers are going to point in the Y direction. So, it sometimes helps if you hold the piece of paper up in front of you so you remember what's going on here. I'm holding the piece of paper up in front of me, so Y is pointing into the screen, into the paper. So my fingers are pointing inside, but in order to get my palm to face Z so I can curl my fingers, I need to sort of flip my hand over, so I end up with my thumb pointing down. So the X-axis is going to be down. So now I'll put my iPad down so I can draw it. Oops, wrong one. Here we go. So there's X. Okay, so now we've sort of made an agreement on how we're drawing pictures, what an arrow towards us means, how we can represent an arrow that's coming out of the page, how we can represent an axis that's going into the page. Now let's talk about if I ask you to spin the frame about one of the axes. So let's suppose that I say, take this coordinate frame that we have right here, so X, Y, Z. First, you should check, whenever I show you a frame now, you should point your fingers in X, curl to Y, and make sure Z goes up so we know we have a right-handed coordinate system. Occasionally I mess up, but I think this one looks good. And suppose I say grab, hold your fingers around, just grab onto Z and rotate it by 90 degrees. So I say grab onto Z and rotate by 90 degrees, and you say to me, well, which way is 90 degrees, right? Because 90 degrees could be grab Z and sort of spin that way, right? Or it could be grab Z and spin that way. And depending on what we get, we end up with X either pointing into the screen or out of the screen, right? So we got to figure out what we mean by this. So just to explain it one more time, you can see that if when I say rotate by 90 degrees, I'm sort of saying rotate by 90 degrees if I'm looking at, z from above, I guess. If I say rotate 90 degrees, if I'm looking at z from above in the, I think that would be the clockwise direction, right? If I'm looking at z from above. Then we end up with x pointing backwards, right? Pointing into the page, right? Y off to the left. Z doesn't change because I'm holding z in place, right? And just rotating around it. But of course, maybe I wanted you to rotate counterclockwise, right? If I'm looking down at the xy plane from above z, if I rotate counterclockwise, then I get something completely different, right? Well, not completely different. Z is still pointing upwards, but now y is pointing to the right instead of the left, and my x-axis is down and sorry, my x-axis is pointing out of the page, which I draw by drawing it down and to the left. So we just need to agree how we're going to do this, which direction we're going to consider to be positive 90 degrees and which direction we're going to consider to be negative 90 degrees. So we just need to come up with a convention, something we agree on. And since most people in the world are right-handed, we tend to agree on rules that are based on our right hand. So that's what we're going to do for this as well. So when we're talking about axis rotation, right, so rotating axes, right, we have a different right-hand rule. It's sort of the almost the inverse of the previous one. And this one says what you do is you point your right thumb in the positive direction of the axis that you want to rotate about. And when you do that, your fingers curl in the direction of positive rotation. So for example, if you look at this picture over here on the left, if this is our original coordinate frame where x is pointing to the left, y is pointing out of the screen, out of the page, and z is pointing up, if we want to do a positive rotation about the z-axis of 90 degrees, we can see that a positive z rotation, in this case, because of the way the fingers are pointing, is sort of, it's not a very good picture, is it? That way around z, right? And so if we rotate about z by 90 degrees, then we end up with this picture on the right here. Okay, let's just do a couple of examples with this axis here, or this set of axes here, this coordinate frame. Why don't we do, let's start by doing rotate x by 180. 180 is a little bit of a weird one, actually, right? Because 180 degrees in either direction is the same, but of course, since we want to at least show that we know what we're doing, we're going to rotate about the x-axis by 180 degrees. So we have to stick our thumb so that our thumb is pointing along the x-axis, which means that our fingers naturally curl this way. So we're going to rotate 180 degrees about the x-axis. So remember, we're kind of holding on to the end of the x-axis and spinning it in a positive direction by 180 degrees. And so in that case, we end up with, let's see, so x stays in the same direction because x is what we're holding on to and spinning. Y, after we rotate by 180 degrees around the x-axis, y is now going to be pointing out to the right, and z, which was down, is going to end up pointing upwards. So that's rotate about x by 180 degrees. Okay. Now, how's about we try another example? Why don't we rotate about the y-axis by negative 90 degrees? And if we do that, let's see, so we're rotating about the y-axis, so we stick our thumb in the direction of the y-axis, which is to the left, which means that our fingers sort of curve around like that, right? So you have to imagine grabbing the y-axis and rotating. Well, let's see, that direction, this is the direction of positive rotation. So if we want to rotate by negative 90, we have to rotate in the other direction. So if we rotate by negative 90, of course, we're rotating about the y-axis, so the y-axis is still going to stay at the same orientation. And by the way, this is important. Of course, I'm rotating my axis. I really, the origin of my axis is going to still be here, right? Is going to be at the same origin. I'm just doing a rotation. I'm not doing any movement, but it's easier for me if I show you, if I redraw it over here than if I try and draw it on top of these axes. But anyway, so I'm rotating. So my y-axis stays the same. I'm doing a negative 90 rotation about y, which means x is going to end up pointing downwards, and z is going to point into the paper. And let's just try this other example here. How's about we do a rotate about z of 90 degrees. So if we want to rotate about z of 90 degrees, we stick our thumb so that it's pointing along the z-axis, which means that our fingers are going to sort of curl around that way. I'm doing a positive rotation of 90 degrees. So as I twist this like that in the positive z direction, let's see, y ends up, so z always stays the same because that's what I've grabbed onto and I'm rotating. And again, let's see, y is currently pointing into the page. So the new version of y is going to be pointing up after I rotate it. And x, which is currently pointing down, is now going to rotate around so that x is pointing into the paper or into the screen, right? And again, just remember that I'm really just doing a rotation. So really what happens is that the origin stays exactly the same, but y is up there, z stays in the same place, and that axis is now x, right? So I'm rotating in place, but it's just usually easier for me to show it if I redraw it off to the side. So now that we know how to draw some axes, I also want to make sure that you know how to draw 3D points on those axes so that things actually look half decent. And so what we're going to do is I'm going to take you through sort of a step-by-step process and just do it the way that I do it. For the purposes of my class, you just got to do it my way. If you have another beautiful way that you like drawing your 3D graphs, or 3D plotting points in 3D, I'm very happy for you to do it that way when you are not in my class. So let me just show you my way. The first thing that you need to do on your axes, let's say we want to plot the point 5, 3, 4 on these axes, is you need to draw the tick marks, you know, the lines that we're going to use. So what I would say is on the vertical axis, the z-axis, you want to draw horizontal tick marks. And then when you're looking at the x and y axes here, you want to think about making tick marks on the x-axis so that the tick marks are parallel with the y-axis, so they're also going to be horizontal. And tick marks on the y-axis that are parallel with the x-axis. So let me show you what I mean here. The tick marks on the x-axis, and in this case it's the x-axis. I don't really care what the letters are as long as we're talking the ground plane. So the tick marks that are going on the in-out axis are also going to be horizontal, and that's because they are lining up so that they're the same as, so that they're parallel to the right-left axis. And the tick marks that are going on the right-left axis, in this case y, they're going to be parallel to the in-out axis, so they're going to kind of look like they're at an angle like this. Okay? So no matter how your axes are going, the vertical, the up-down axis, this the one that's currently labeled Z, is going to have horizontal tick marks. And for these two, which are sort of these two axes, whatever their names are, the one that is going left to right is going to have these diagonal tick marks, and the one that's going in out is going to have horizontal ones. And let me just show you. So there it is, drawn a little bit more beautifully. So that's step one. You just draw your tick marks. And now what we're going to do is we are going to determine which two axes lay on the ground or form the ground plane, as it were. So in this case, you can see Z is going up and down, and the XY axis the XY axes form the ground plane where you would be sort of standing if you were standing on the ground. So we're going to figure out, okay, we need to get the X and the Y coordinates. So in this case, that's the 5 is the X and the 3 is the Y. And we're going to draw two lines on the ground plane corresponding to that. So the X axis has a 5, so we need to go 1, 2, 3, 4, 5. We're going to go about here, and we're going to sort of draw as straight a line as we can here, parallel to the y-axis. And then we're going to, on the y-axis, we need to count out 1, 2, 3. And we're going to go along in the direction of our tick marks here. And this really should be parallel to the x-axis there. And then let's just erase the extra little bits here. There we go. All right. So now we have our two lines on our ground plane. So if you were to look at this point right here, right, that is actually the point 5, 3, 0. And we would be better off if we just labeled a little 5 there and a 3 there. So we know that that's the point 5, 3, 0. So we've done step 1, we made the tick mark. Step 2, we plotted the point that was going to be on the ground plane. So 5, 3, 0, right? And here's a nicer version of the drawing after you've drawn the two lines on the ground plane and labeled them. And now, as it says here in step 3, what we need to do is we need to draw a perpendicular with tick marks and our point. So right now we're trying to do the z coordinate, which is 4. So I'm just going to go in the positive 4 direction, which is this direction, right? I'm going to go 1, 2, 3, 4. And I'm going to put a big blob there signifying that's where my point is. And then I'm going to label my point. And in this case, because I'm sort of right on the other, since I'm so close to the z-axis, I'm just going to write 5, 3, 4 here. And here you can see I've just drawn it a little bit more clearly. So now let's try plotting the same point, except we're going to plot it on an axis where x is pointing to the right, z is pointing down. So now we got to figure out x goes to y, y goes to z, z goes to x. So if I go from z to x, so my fingers are pointing along z with my palm pointing towards x, and I curl my fingers out, it looks like my y-axis is sticking out of the page. And so now I want to start by drawing my tick marks again. So there's the up-down axis, whatever it is, gets horizontal tick marks. And then the in-out axis also gets horizontal tick marks. And the other axis on the ground plane, the left-right axis, is going to get some diagonal tick marks. There we go. And let's see. So we're going to start by plotting the point on the ground plane, right? We're drawing those two lines on the ground plane. So in this case, the ground plane, oh, well, this is good. The ground plane is still formed by x and y, so we got to figure out the 5 and the 3 again. So x is 5, so we got 1, 2, 3, 4, 5. Maybe we'll change colors and we'll do, there's kind of my x. And notice again that it's parallel to the y-axis when I'm drawing this line. And the y is a value of 1, 2, 3. So we're going to draw a line from here that intersects that other one. And then we'll just erase what we don't need. Not doing a brilliant job of erasing. There we go. All right, so now on our ground plane we have the 5 and 3 taken care of. And now we need to do the 4, and it's positive 4 along the z-axis. So we got to draw our perpendicular along in the positive z direction, and we'll go 1, 2, 3, 4. Let's actually just move everything up a little bit so you can see it. My fourth tick didn't actually make it in there, but there's my fourth tick. So I'm going to do a big blobby there, and I will write a 4, right? And so this is actually the point. Let's erase that thing that makes it look like it says -4. There we go. And so again, we have the point 5, 3, 4. And you can kind of see when you look at this, I think that once you kind of get used to these images, you can see kind of I'm defining the ground plane, right? So here's the bit on the ground, and then we stick down an additional 4 from there. And let's just do one more example. This says we want y going right and z going into the page. So y goes to z gives us x, so x is going up and down. And we want to plot 5, 3, 4. Notice now that the ground plane is formed by yz, right? That's the ground plane. So when we start plotting points, we're going to start with our yz, drawing those guys in first. But let's see. So the up-down axis, we give horizontal tick marks. The in-out axis, we also give horizontal tick marks. But the left-right axis, we give tick marks that are parallel to our in-out axis. And so we have to plot 3 along the y and 4 along the z. I'm doing this in multiple colors just so it makes it a little bit clearer. But here's 3 on the y. So we're going to kind of go out that way. And 1, 2, 3, 4 along the z. Notice I'm sort of continuing the direction of the tick marks, right? And then we'll just erase that extra little bit. And let's just write in that that y was 3 and that z was 4. And now we need to go 5 in the x direction. So let's make our up axis and go 1, 2, 3, 4, 5. And there's our point. Okay, let's do another example. 1, 3, 5. If x points up and y points into the paper, there's y, there's x. So x is up, y is into the paper, so my z for right-handed coordinate system is that away. So my ground plane again is yz here, right? So we're gonna draw our little tick marks. And we're gonna have horizontal tick marks on this guy and diagonal, tick marks on this one. And I'm drawing on an iPad with a yucky stylus, so my hand drawings are not as beautiful as yours should be when you can draw with a ruler and a pencil or what have you. But anyway, so we're looking for, we want to go 3 out in the y direction, so that's going to be kind of like that. And we want to go 5 in the z direction, so that's 1, 2, 3, 4, 5. Oops. So we're going to kind of go like that, and let's erase the extra as good as I can erase. And then we need to go 1 in the positive x direction. So we'll have, there's our x, but we're only going 1. So there's my point, right? And that's at 1. And that is the point, actually, if we want to label it. Normally, if I were drawing this on paper, I would have more room and I could put the actual 1, 3, 5 right next to my point. Unfortunately, I don't have that much space, so I'm going to do it slightly differently. And then the, so that was the first one, right? And now let's try and do the second one. So now we want to do it again, but this time it says we want to do an example where we have y pointing down and z pointing out of the paper. So from y to z gives us x pointing out to the left. So you draw your tick marks, and the up-down axis always has horizontal tick marks, as does the in-out axis. And the horizontal one is getting our diagonal tick marks, and our ground plane is formed here by x and z, and we are plotting 1, 3, 5, right? So we're going to go 1 along the x, so there's 1 on the x, so it goes like that, and we have to go 5 along the z. I guess my one line is going to have to go further out. We go 1, 2, 3, 4, 5, so we draw a line out there. And then that should actually be sort of horizontal there. That's a bit better. And let's erase the extra yuck. There we go. All right, so now we've plotted the 1 and the 5 part, and we still have to do the 3 in the positive y direction. And it looks like y is going down, so we need to go 1, 2, 3. There you go. So just a couple more things to talk about. It's often the case when we're working in robotics that we will be working with multiple coordinate frames simultaneously. So in this example, we have tower coordinates, which I've given a subscript t to. So we have the x, y, and z orientation of tower coordinates, and we can check to make sure that's a right-hand coordinate frame. It looks pretty good to me. And then maybe the airplane has coordinates that have a subscript of p, so we have x, y, and z coordinates for the plane. And again, I check and I go from up to, which is x, to into the paper, which is y, and my z does indeed point to the left. So we might want to talk about things like, where is the nose of the plane in tower coordinates, or where is the origin of the tower in plane coordinates? So let's just take a look at these different questions. So the first one is, what is the location of the nose of the plane, right, in tower coordinates? I sort of colored that in badly, but anyway, I'm not crossing it out. We're doing that one. The location of the nose of the plane in tower coordinates. And you can see I've drawn in here just some sort of random numbers. So in tower coordinates, this is along the x-axis. In plane coordinates, this is along the z-axis, but either way, it's 50 meters sort of left-right between the nose of the plane and the origin of the tower. But in addition, it looks like the tower is 5 meters sort of closer to us than the nose of the plane along the plane's y-axis, or actually it's also the tower's y-axis. So if we want to know where is the nose of the plane in tower coordinates, well, we're going to start in tower coordinates. So there's our origin. And we need to go 50 meters along x, and then we need to go 5 meters, along y, pretend that's at the nose, and it looks like our z-axes are at the same level. So the location of the nose of the plane in tower coordinates is going to be 50 along the x-axis of the tower and 5 along the y-axis of the tower, and 0, and 0 along the z-axis of the tower. So that's the location of the nose of the plane in tower coordinates. Now let's talk about the location of the origin of the tower in plane coordinates. So now we're looking at the plane coordinate frame. And in the plane coordinate frame, there's no difference that the first axis is the x-axis, and there is no up-down difference, so we're going to have a 0 there. And let's see, the origin of the tower is closer to us than the nose of the plane, so it's kind of 5 meters in this direction, but that's the negative y direction. So we have to say -5 here. And then for the last coordinate, we start at the nose of the plane, and we need to go 50 meters along the z-axis, and that's along the positive z-axis. So that's 0, -5, 50. And then our last question here, let's do this last one, the location of the nose of the plane in plane coordinates. Well, the nose of the plane is located exactly at the origin of the plane, right? So that's just at 0, 0, 0. Now, as I said before, most of the time we're going to be working with coordinate frames that sort of have one axis in the vertical, one axis in the horizontal, and one axis in the in-out plane. But what happens here is suddenly our airplane has done a little bit of a rotation so that things are a little bit messier now. Drawing some lines to show us the math for the location of the the location of the nose of the plane in tower coordinates, right, isn't too bad. We can just find out where is the nose of the plane in tower coordinates, and we did our little lines here, and if we know what those distances are, everything is easy and we can plot that point. And similarly, we can plot, if we want to know what's the location of the origin of the tower in plane coordinates, well, here's a reminder of what our plane coordinates were when our plane was nice and horizontal, and now our plane has sort of tilted up a bit, and you can see that it gets a little bit yucky, right, when we're doing this in terms of the drawing, because now, x is the x-axis is kind of tilted back a little bit. The z-axis is sort of tilted up a little bit. The y is still, assuming our plane is straight in out, but if we're trying to figure out the location of the origin of the nose of the plane, of the tower in plane coordinates, we now need to, we now need to redraw things so that our plane axes are labeled. And it's pretty yucky when we're doing it in these weird angles, but z kind of goes up like that, and x kind of goes like that, and y is going into the page. But of course now it's sort of hard to see, is x going into the page or is y going into the page? So it's much nastier to draw, but you can understand that we could still figure out what is the location of the origin, what is the location of the origin of the tower in plane coordinates, and what's the location, what's the location of the nose of the plane in plane coordinates? Well, that's still, the nose of the plane is still at the origin of the plane coordinate system. So the nose of the plane, no matter what angle the plane is always going to be at 0, 0. So that's a super easy one.